Hey guys, it's Mr. Powell, and today we're going to be talking about acceleration, gravity, free fall, mass, velocity. We're going to be talking about all those things and how they're all interrelated. I'm not going to talk a whole lot about the math behind it, but I'll talk about the terminology, the vocabs, and I'll go over the formulas. So let's just get into this right now, and I'll cover the math later. Free fall is acceleration due to gravity. An object is in free fall if it is accelerating due to the force of gravity with no other forces acting on it. On Earth, free fall is going to be 9.8 meters per second squared. That's going to be a constant because the Earth's mass never changes. So 9.8 is going to be constant here on Earth. If we would go to the moon, that would change because the moon has less mass than the Earth. So its gravitational pull is going to be less. If we go to Jupiter, it would have a greater gravitational pull because its mass is much larger than Earth's. Okay. Free fall speed, this is the formula for it. So the first thing you have is your time, and that's the amount of time something was falling. Then you have the force of gravity, and it's going to be 9.8 meters per second squared on Earth always. That's a constant. And then finally you have your speed or velocity. This person up here, they're dropping a ball, and the ball will start out with an acceleration of 0 because it's in their hand. But once that ball drops, the second after it drops, it's going to be at 9.8 meters per second squared. After 2 seconds, it's going to be at 19.6 meters per second squared. And after 3 seconds, it's going to be 29.4 meters per second squared. Every second, it gains 9.8 meters per second squared as it drops. Alright, so I want to point some things out. This plus and this minus, they're not negatives and positives. They're representing direction. So this is going in an upward direction, the pluses show that. This minus shows that it's going in a downward direction. So this guy applies a force to this ball, and it's accelerating at 19.6 meters per second squared. After 1 second, gravity, which is going the opposite direction of the ball, the force acting on it, it's pulling it down. Because that, gravity will subtract 9.8 meters per second squared every second. So if you take 9.8 and you subtract it from this, you'll get 9.8 meters per second squared. And if I subtract another 9.8 meters per second squared after the next second, we'll be at 0. And the ball will actually stop accelerating. It'll stop moving, and then it'll drop back down. And the first second it comes down, it'll gain an acceleration 9.8 meters per second. And then after 2 seconds of that, it'll be at 19.6 meters per second, heading in downwards. All right. Gravity is constant throughout this. That never changed. It was 9.8 going down the whole time. All right. The acceleration of the ball going up stopped right there, and once that stopped, gravity took back over and pulled it back down. This is the formula for average speed. You take the ball's final speed and you take its initial speed, you add those together, and you divide them by 2, and that'll give you average velocity in meters per second squared. If you have the average velocity, you can plug it into this formula, free fall distance formula, and it will tell you how far something fell. So you'll take the average velocity, which is what we found in the last formula, and you'll multiply that by the time that it fell, and that'll give you the distance that it fell. Alright, air resistance and terminal speed or terminal velocity. Air resistance is the opposing force on an object as it's falling. If you think of a parachute, that's a good example of this. As somebody jumps out of a plane, that parachute opens up, that air fills that chute, and the force of the air pushes up against it, and it slows the person as they drop to the earth from a plane. Terminal speed, this is the maximum speed an object can reach once air resistance and gravitational force reach an equilibrium. And their speed becomes a constant at this point. They don't speed up or they don't slow down, they just keep dropping at the same speed. That's terminal velocity. I hope this was beneficial to you. If you didn't understand something, go back and watch it. And like I said again, the math will be in a separate video, so if you want to learn more about those formulas, you can check that video out.